In step 6, we're going to be talking about writing equations and inequalities and graphing. This might seem like review from Algebra 1, and some of it we've actually touched on already this year in Algebra 2. However, we're going to focus a little bit more in depth on all of these particular topics. Let's start with linear equations. There are 3 forms of a linear equation. They can be in slope-intercept form, point-slope form, or standard form. Those are our 3 choices. They are all perfectly acceptable forms. Certain situations, one form will be better than another form, and that's what we're going to explore. Let's start by talking about slope-intercept form, one of the most common forms. This is the form where all the lines will have a y and an x, or at least one of them, y or x. They will have a slope, which is the coefficient of the x, and they will have a b, which is the y-intercept. Now, a couple of ways that we can remember this information. The slope is represented by the letter m, and it kind of looks like ski slopes, like hills. The y-intercept is always represented by the number by itself, and that number when graphed will always be on the y-axis because by is a word, by, but bx is not a word. So we would never put that value on the x-axis. It will always be on the y-axis. If we are given the slope and the y-intercept of a line, we can write the equation by simply putting in the value for n and the value for b. For example, with this first graph, we have a picture of a line and we want to basically write the name. Almost imagine if you had a photograph of a friend and you just wrote the name of the person in the photograph. That's what we have here, a picture of the line. Now we're going to write its name. We're going to write its equation. It says slope-intercept form, so those are my ingredients that I need to use. I need the slope, I need the intercept, and to be even more specific, I need the y-intercept. When I look at this line, think back to step 5. We go down 1, right 4. So my slope is -1/4. My y-intercept is where this blue line crosses the y-axis, which is right here at -2. Or more specifically, the point 0, -2. So when I create my equation, y equals mx plus b, I'm simply taking out m, putting in the slope, taking out b, and putting in the y-intercept. Now I don't want to have plus minus, so I'll just put subtract 2. This is the equation of this graph. How about the next one? We want it in slope-intercept form, which means I need a slope and I need an intercept. Is this the y-intercept? Yes, it is. It crosses at 0, 4, which is a point on the y-axis. So y equals mx plus b. Over here, it gets a little bit more complicated. Now we're supposed to use slope-intercept form. Think about what ingredients we need to use slope-intercept form. We need a slope, and we need a y-intercept. Well, recall, y-intercepts are all of the form 0, a number. So we do have a y-intercept right here. We do have that. But we don't have a slope. Fortunately, from step 5, we know how to find the slope of a line given 2 points. So we're in good shape. We're simply going to use our slope formula off to the side. We'll put -6, 10, 0, -4. We'll reduce and get -16/4. Which is -4. So really we do have a slope. It was just hidden. So now we write our equation. Y equals mx plus b. How about this next one? Write an equation of a line. They give us a point. They do give us a slope. So think about our ingredients. We need a slope. We need a y-intercept. We don't have a y-intercept. That's unfortunate. But we do have some options. We have another form of a line called point-slope form. Just like the recipe suggests here, the ingredients are a point and a slope. And that's precisely what we've been given. I recopied the example right down here as well. We've been given this point that's not a y-intercept and the slope. When we have that, we are going to use point-slope form instead, where you put the slope in and you put the x and y coordinates into the formula as well. It's going to have some parentheses, and we can convert this to slope-intercept form if the problem asks us to. But if it doesn't ask us to, it's perfectly acceptable to leave it in point-slope form. Let's think about what this formula says. It says take y and subtract the y coordinate of the point that you've been given. Then it says take m and multiply it by the x minus the x coordinate that you've been given. So I'm going to take out each one of these values and place its corresponding value in there instead. So the slope is -4. Now, be very careful not to take out the wrong x and y. In fact, when I start my point-slope problems, I usually don't write 2 y's and 2 x's because sometimes I think it can be confusing which one to remove. So I do y subtract the y equals m x subtract the x value. And now I know, put the y value next to the y. Notice I changed it to +2 because there was already a minus in my formula. And I'm going to put 6 next to x. Now I'm finished. This is an equation of a line through this point with a slope of -4. If you'd prefer to get it in a slope-intercept form, that's perfectly fine. Think about what slope-intercept form looks like. Y is by itself on one side, and there are no parentheses. So we can get it into that form quite easily. We're just going to need to distribute to remove the parentheses. Y plus 2 is -4x plus 24. I can subtract 2 from both sides. Y is -4x plus 22. Now, there is a way to do this without point-slope form, and I will leave that for you to do in class with your teacher. I also want to take a moment to show you what this would look like when we graph it. And I want to do it 2 different ways. One way is to start with our slope-intercept form that we came up with. Y equals -4x plus 22. And another option is to begin with the information we've been given. We can plot a point, 6, -2. Would be right here. I'm having trouble with my pen today. 1, 2, 3, 4, 5, 6, -2. And a slope of -4 means go down 4, right 1. Down 4, right 1. Or up 4, left 1. Up 4, left 1, and so on. Notice I can't even get this particular line all on the graph. It won't ever intersect the y-axis actually because the y-intercept happens at 22. So we'll just do the best we can to get our line on there. And we've graphed the line. In order to practice graphing given this original equation, and the fact that my graph isn't large enough to accommodate 22 on the y-axis, I'm just going to make up a new problem to practice graphing instead. And the new problem will be y equals negative 3x plus 5. If I wanted to graph this line, I would begin at 5, begin with B, and I'm going to go down 3, right 1. You can do that all the way across your graph till you have enough points that you like, and then simply connect your points. Take time to make it as precise as you can. Let's practice using point-slope form with 2 more examples where we are given a point and a slope. What would this be simply in point-slope form? Y minus y equals m times x minus x. And we're going to put here. This is the x value, it goes on the end, and the slope is in the middle. If I wanted to go to slope-intercept form, I need to distribute. And I also need to get y by itself. I need to isolate y. Both of these would be acceptable answers. If it specifies for one form over the other, you need to be sure to give your answer in that form. Pause the video and go ahead and try B. Hopefully you got y equals negative 3x minus 7 for your answer. What if they don't give us a slope? They give us 2 points. We don't have a form of a line called point-point form. It doesn't exist. We have point-slope and slope-intercept. But the fact that we are given 2 points implies that it would make sense to start with our point-slope form. Y minus y equals m, x minus x. And remember from step 5, just because they didn't provide us with a point, or a slope rather, we can find that slope very easily. We're just going to put it into our slope formula, and we're going to simplify, which gives us 10 over negative 5, which is negative 2. Now, it becomes a little tricky to think, well, which numbers go in the equation? First of all, you have to pick your favorite point. You might say, well, I don't have a favorite point. Sure you do. Everybody has a favorite point. I'm going to choose, for this example, I'm going to choose this point, which means I'm just going to cross out the other point. I don't need it anymore. I used it to find the slope, and now I can get rid of it. I don't need it any longer. I'm going to now use the point and the slope that I have, just like we did above. Y minus y, m, x minus x. And I'm finished. Now, I'm going to distribute and get it into slope-intercept form. Y minus 7 is negative 2x minus 4. Add 7 to both sides. If I had chosen the other point, when I reduce it to slope-intercept form, I will get the same answer. Feel free to try it. It will work. If you use the point 3, negative 3, you will get this same line. So let's graph it. Let's begin at 3. And we're going to go down 2, right 1. The more points you can place, the better, because that helps give your line some direction and keep it as precise as possible, especially for the steps that are coming ahead. We want as much precision as possible. Try to move that line a little bit so that it actually goes through all my points. Sometimes I need to do that with my keyboard. There we go. Much better. take a look at the next one. We have a point. In fact, we have 2 points, but we don't have a slope. So let's start by figuring out the slope. I'm going to subtract my y's on top. -7 take away 6, and on the bottom, 4 take away 4. That gives me -13 over 0. If you type that on your calculator, you'll get an error. This is undefined. Does that mean we can't write the equation? No. We know from step 5 that undefined means x equals some number. Well, what does x equal? Well, let's look back. What does x equal in the first point? 4. What does x equal in the second point? 4. So if we have to choose some value for x to equal, it makes sense that we would choose 4. And we're finished. And you might wonder, well, is that in point-slope form? Is it in slope-intercept form? It's kind of one of those outliers. It's really neither because we don't have an x and a y. It would be in standard form, which we're going to get to later on in our notes. Let's try practicing writing the equation when we're given the picture, as we did above. Here we know y equals mx plus b. What is the slope? Well, I'm going up 2 over 5. 2 over 5. And what's the y-intercept? 2. Pause the video and try 6 and 7 on your own. Did you get y equals 3/2 x plus 3 and y equals -2/3 x minus 2? That would be correct. Let's talk about standard form, our third form of a line. Standard form is when x and y are on the same side, the left side of the equal sign. X and y have coefficients that are not fractions, they are integers. That means no fractions. And the coefficient of x must be positive. Now, the coefficient of y can be negative, but the coefficient of x must be positive. And that's what it says right here. The coefficient of x is a must be greater than or equal to 0. A and b, the coefficients of x and y, cannot both be 0. One of them can be, but not both of them. And the greatest common factor between all 3 of these numbers must be 1. If you can divide by 2, you need to do it. If you can divide by 12, you need to do it. Okay, let's practice getting these into standard form. Remember, our criteria, we want x and y on the left side with no fractions. The coefficient of x must be positive. Let's see. We don't want any parentheses, so let's distribute first. That's step 1. Get rid of the parentheses. Now, we have y on the left, but we want x on the left as well. So I'm going to move the x term to the left side by subtracting it. -3x plus y minus 11 is -6. We're getting closer, but I only want the x term and y term here. I do not want a constant term with it, so I'm going to add 11. Now I have -3x plus y equals 5. I don't have any fractions. X and y are on the same side, on the left side. However, the coefficient of x must be positive. So I need to multiply this equation by -1, or a simpler way to think about that, change all the signs. 3x, -y, -5. That is my final answer. Let's try the next one. Here we have a negative to distribute. Y minus 10 is negative x plus 2. I want to add x to both sides because I want x and y on the same side. I'm going to add 10. So x plus y equals 12. And I'm done. X and y are on the same side. There are no fractions. We're good to go. Let's look at this one because we're going to end up with a fraction because we have a fraction that we're starting with. Y minus 5 equals 3/2 x plus 3 times 4 makes 12 divided by 2 is 6. I cannot have fractions. I'm going to get rid of this fraction right away by multiplying the entire equation by 2. 2 times y makes 2y. 2 times negative 5 makes negative 10. 2 times 3/2 is just 3x. 2 times 6 makes 12. Now I can move x to the left. I can move negative 10 to the right. I'm left with negative 3x plus 2y equals 22. And again, I cannot have a negative leading coefficient of x, so I'm going to multiply it by negative 1 or change all the signs, and I'm left with 3x minus 2y is negative 22. What if we have a decimal? Y minus 3 equals negative 2.4x minus, well, that would be a plus, 12. Notice I have a problem here because I have a decimal. In order to get rid of this decimal, if I multiply this entire equation by 10, I'll end up with 10y minus 30 equals negative 24x plus 120. I no longer have a decimal. A decimal is just as illegal as a fraction. We have to have all integers. But notice now, looking at this, there is a greatest common factor. All of these numbers are even. So I could divide all of them by 2. And I'm left with 5y minus 15 equals negative 12x plus 60. I can divide 5, 15, and 60 by 5, but I can't divide 12. And these are even, but these are not, so I'm good. So now I'm going to put the negative 12x on the left side. I'm going to put the negative 15 over to the right side, and I end up with 12x plus 5y equals 75 when I add 15 to both sides and add 12x to both sides. The very last thing I want to do is think about taking this equation that started in point-slope form. We converted it to standard form. Let's go ahead and take it and put it into a slope-intercept form. In order to do that, I could subtract 12x from both sides. And then I could divide everything by 5. Y equals negative 12/5 x plus 15. I like to have my x term first, followed by my constant, but if you had 15 minus 12/5 x, that would be fine as well. I want to show you that so that you can see that this same equation can be written 3 different ways: in slope-intercept form, in point-slope form, and in standard form.